Hi, this is A-level physics, paper 1. Paper code is 9702, paper variant is 12, year is October November 2019. Let's solve it. Question number 1. It says that a cyclist has a speed of 5 meters per second and a small car has a speed of 12 meters per second. Which statement does not gives a reasonable estimate? It says not gives a reasonable estimate. So part A says the kinetic energy of a cyclist. Okay, so kinetic energy of a car, the momentum of a cyclist, the momentum of a car. Now for these types of question, we must know the average age of the objects. Like for, let's suppose that for a cycle, a small cycle is almost 10 kg. So we can assume it to be 10 kg, and man average weight is about 70 kg. So and a small car or an average medium car has a weight of about 1200 kgs. So we can estimate the kinetic energy from our data that we have assumed. The kinetic energy of the cycle of the cyclist plus man will be around 1000 joules, and the kinetic energy of a car will be around 72,000 joules. So that's A and B are correct. C says the momentum of a cyclist. So momentum 1200 into 12, like the mass of car is 1200 into 12 is 14.4 into 10 raised to 3. So that's also correct. So C is also correct. D, the momentum of car is 2 into 10 raised to 5. That's the only option which is left. So that's the required option, D. Question number 2 says which expression gives an SI base quantity? Part A says charge per unit time. Charge per unit time is current. So that's a base quantity. So that's correct. Part B says force per unit area. Force per unit area is pressure. So pressure is not a base quantity. Mass per unit volume. Mass per unit volume is density. So that's also not a base quantity. Work done per unit distance. That is basically force. So that is also not a base quantity. So A is the answer. Question number 3 says which list contains only scalar quantities? Part A, it says area, length and displacement. Displacement is a vector quantity, so A is not the answer. B says kinetic energy, speed and power. They all are scalar quantities, so B is the required answer. In C, momentum is a vector quantity, and in D, velocity is a vector quantity. So the answer is B. Question number 4 says that a micrometer is used to measure the 28.5 millimeter width of a plastic ruler. The micrometer reads to the nearest 0.01 millimeter. What is the correct way to record this reading? What you have to do is convert this millimeter to meters, and this nearest the uncertainty value also to meters. So this will be about 2.85 into 10 raised to negative 2 and 0.001 into 10 raised to negative 2 meters. So just arrange it in this form and then you will get the answer, which is C. Question number 5, it says the sides of a wooden block are measured with calipers. The lengths of the sides are measured as 20 millimeter, 40 millimeter and 10 millimeter. The caliper can measure with an absolute uncertainty of 0.1 millimeters. What is the percentage uncertainty in the calculated volume of the block? To find the percentage uncertainty, what we have to do is that we have to write the formula of uncertainty, that is change in V over V equals change in length over length plus change in breadth over breadth plus change in height over height, and simply substitute the uncertainty and the actual reading values into this expression, and we will get change in V over V to be 0.0175, and simply multiply it with 100 to get 1.8%, which is B. Question number 6 says that a ball is thrown vertically upwards from ground level and reaches a maximum height of 12.7 meters. Before falling back to the ground level, assume air resistance is negligible. What is the total time for which the ball is in the air? You simply have to apply the formula of S equals ut plus half it square, and this will give you the time from ground to maximum height. After you find that time, just multiply the time with 2, because that's the same time it takes to come back. So it's 3.2 seconds. Question number 7 says a snooker ball has a mass of 200 grams. It hits the cushion of a snooker table and rebounds along its original path. The ball arrives at the cushion with a speed of 14 meters per second and then leaves it with a speed of 7 meters per second. The ball and the cushion are in contact for a time of 0.6 seconds. What is the average force on the ball by the cushion? To find the force, average force, you have to realize a formula. Basically, you must know a formula, that is force is equals to change in momentum divided by time. Over here, we have to find the change in momentum. The change in momentum is basically mass into velocity. We know that the ball rebounds, so it's basically 2mv. So what we can do is that we have to add point mass is, how much is the mass? Mass is 0.2 kilograms. So 0.2 into, add the velocities up because it's rebounding, because it's the final velocity minus the it's the velocity after rebounding minus the velocity before rebounding. So you just add them up, 14 plus 7, and the change, and simply substitute it into the force formula, which is change in momentum over time, which will give you 7 Newton. So D is the correct answer. Question number 8 says a tennis ball is released from rest at time t is equal to 0 and falls through air for a long time. Which graph of its displacement S against t best represents the motion of a ball? So you must realize that the fall is through the air. Initially the velocity is minimum, then the velocity becomes constant as it reaches constant velocity. So you see, that's a displacement line graph. The gradient of this will represent velocity. So over here the velocity is constant, over here the velocity is constant. So B and C are not the options. Considering D and A shows that the velocity has initially increased, but we know that if a tennis ball or any object is released from rest in air, its initial velocity is less and then it attains velocity. So D seems to be the reasonable answer. So question number 9 says the space probe Rosetta was designed to investigate a comet. The probe consisted of an orbiter and a lander. The orbiter had a mass of 170 kg and the lander has a mass of 100 kg. When two parts separated, the lander was pushed towards the surface of the comet so that its change in velocity towards the comet was 3 meters per second. Assume that the orbiter and the lander were an isolated system. The orbiter moved away from the comet during the separation. What was the change in the speed of the orbiter? Initially they both were at rest, so what you can say is that before collision they had a total momentum of 0. So after collision this lander moves downwards, so we can take this down direction as a negative direction and that upward direction which we have to find as a positive direction. So what we can do is that 0 momentum before collision equals momentum after collision. So 0 equals 170 mass of the orbiter into velocity of the orbiter, which we have to find, plus -3, the velocity of the lander mass, a lander which is downward, so we are taking it negative, into 100, which is the mass. So just evaluate it up, we will get 1.76 meters per second, which is roughly 1.8 meters per second. So A is the appropriate answer. Question number 10 says a positively charged oil droplet falls in air in a uniform electric field that is vertically upwards. The droplet has a constant terminal velocity V0 and electric field strength is E. The magnitude of the force due to air resistance acting on the droplet is proportional to the speed of the droplet. Which graph shows the variation with E of V0? So over here we have to realize that the force, because of the air resistance, is proportional to the speed of the droplet, and electric field strength is force over charge, and it is also equals to voltage divided by the distance between the plates. So over here we can say that the force is inversely proportional to E and V is inversely proportional to E. So when E is 0, the droplet falls with terminal velocity decreases linearly. So we can see the relation of V and E. They are directly proportional. Basically it's not inversely proportional, they are directly proportional but with a negative sign. Sorry, that's a mistake over here. They're directly proportional but with a negative sign. So A is appropriate answer. Question number 11 says a rigid uniform bar of length 2.4 meter is pivoted horizontally at its midpoint. Weights are hung from 2 points on the bar as shown in the diagram. To maintain equilibrium, a couple is applied to the bar. What is the torque and direction of the couple? What we can do is simply apply clockwise moment and anti-clockwise moment to this diagram, and by this we can say that the clockwise moment is because of this 300 Newton force. So this 300 Newton force is 300, and the distance between this whole distance is 1.2, because this distance is 2.4. So this distance is 1.2. So if this is 1.2, then 1.2 minus this distance is 0.8. 1.2 minus 0.8 is 0.4. So 0.4 into 300 newtons is 120, and the anti-clockwise moment is 200 into 0.8, this distance. So we can see that if this is an equilibrium, so this clockwise moment shouldn't be 120, it should be 160. So there is a discrepancy of 40 Newton meter, and in which region it is the clockwise moment, clockwise moment. So we can say that a 40 Newton meter clockwise is needed to maintain the equilibrium of this situation. Okay, so 11A. Question number 12 says two coplanar forces acts on an object as shown. Which diagram shows the resultant force of the two forces? Just add them up using the parallelogram law, and you will notice that this is the direction of the resultant force, and this is something, this would be the rectangular representation of it. Let's see, D shows it clearly that F is the resultant force. This is these are the arrows of the components of that resultant force. Question number 13 says that 4 measuring cylinders are filled with same liquid to heights shown. At which height is the pressure the greatest? That's a simple application of pressure equals rho GH. You have to know that this H is measured from the liquid's top height. Like this H is from the surface, and then it's 0 at the surface, and then it goes down and down and down. So at this point, this distance is greatest. Over here it's 0, over here it's 0, over here it's 10, and over here it's more than 10. Okay, it's about 20 centimeter. So that's the greatest pressure. Question number 14 says the gas in an engine does work on a piston of cross-sectional area 80 centimeters square. The pressure on the piston has a constant value of 4.6 into 10 raised by 5 pascals. How much work is done by the gas on the piston when it moves through a distance of 25 centimeters? Simple application of work done equals pressure into change in volume. We know the pressure, which is 4.6 into 10 raised by 5. We know the area, which is 80 into 10 raised to the power negative 4, and we know that the distance moved, which is 25 centimeters. So converted into meters, 0.0025 meters. So just evaluate it up, and it will be 9.2 into 10 raised by 2 joules. Question number 15 says a power station using coal as fuel and has an average output of 3000 megawatt. Coal is supplied by 20 trains each day. The efficiency of the station in converting the thermal energy released from the coal to electrical energy is 26%. A mass of 1 kg of coal will release 33 megajoules of thermal energy when burned. Which mass of coal does each train bring? Which mass of coal does each train bring? You have to simply apply the formula of power output efficiency. So you know that the power output is 3000, the efficiency is 0.26. So what we can do is find the power input. The power input, by we know the efficiency, we know the power output, the power input we get is 11538 megawatts. So just use this power input and find the energy. How to find the energy? We know the time, how much time it is. It is basically whole day. So what we can do is whole day is 24 hours, 24 into 60 into 60, so it's 86400. So energy, find the energy, multiply this power with 86400, you will get the energy. From this energy, divide this energy by 33, because each 1 kg of coal releases 33 megajoules of energy. So this will give you 3 into 10 raised by 7. That's for 20 trains. Now for one train, they divide it up with 20, which will give you 1.5 into 10 raised to the power 6 kg. So C is the appropriate answer. Question number 16 says a wooden cylinder floats partially submerged in a bath of water. A force F is applied to the cylinder until it is just fully submerged. Which statement is not correct? Some of the water gains gravitational potential energy. The cylinder loses gravitational potential energy. Work is done by force F on the cylinder. Work is done by the upthrust on the cylinder. That's the most appropriate answer, because upthrust is opposing force to weight, and it is because of the work is done by the upthrust. So question number 17 says a motor of a crane lifts a load of mass 600 kg. The load rises vertically at a constant speed of 12 meter per minute. What is the useful power output of the motor? So what we can do is apply P is equals to Fv, power is equals to force into velocity, and velocity it's 12 divided by 60. So 12 divided by 60 is not 12 divided by 60, it's 12 multiplied by 60, because seconds is in the denominator, so the 60 would come up and multiply with the 12. So 600 into 10 into 12 into 60, so this will be 1.2 kilowatts. Question number 18 says the graph shows the effect of applying force of up to 5 Newton to a spring. The spring obeys Hooke's law for forces up to 7 Newton. What is the total extension of the spring produced by the 7 Newton force? So what you can do is find so it's simply 14 minus 11 is 3 divided by 5 into 7. Simple proportionate formula. So it's 4.2 centimeter. What is the total extension? So it's 4.2 centimeter. Say. Question number 19 says a rubber cord hanging from a rigid support, a weight attached to its lower end is gradually increased from 0 and then gradually reduced to 0. The force extension curve for contraction is below the force extension curve for stretching. What does the shaded area represent? This shaded area represents the thermal energy dissipated in the cord, or which you can say the hysteresis loss. So it's B. No need to spend more time on the options. It's a straightforward question. Question number 20 says a transverse wave is traveling along a rope. The frequency of the wave is 2 Hz. The graph shows the variation with distance of displacement of the wave at time t is equal to 0. This is at time t is equal to 0, which diagram shows the position of the wave at time t is equal to 0.5 seconds. So after 0.5 seconds, what would be the situation of this wave? The frequency is 2 Hz, so the time period is 0.5 seconds. So it's basically asking you, after one time period have passed, what will be the situation of this? So as you can see, if it's 6 to 8, it's 2 meter. So this wave will move here, and this wave will move here, this wave will move here, this wave will move here, and this wave will move here, and a new wave will be generated here. So 1, 2, 3, 4 and 5. There will be 5 waves of complete period from 0 to 10 at t is equal to 0.5 seconds. So question number 20, the answer is D. See? Question number 21 says the two graphs represents the same wave. Graph 1 shows the variation with time of the displacement at a particular distance. Graph 2 shows the variation with distance of the displacement at one instant. What is the speed of the wave? The formula for speed is v equals f lambda. We can find the frequency from graph 1, which is we can find the frequency. The time period is 0.5, so frequency is basically 2. From graph 2 we can find the lambda, which is the wavelength. So the wavelength is basically 60 centimeter or 0.6 meters. So just multiply them up. 2 into 0.6 gives 120 centimeters per second. D. Question number 22a says a microphone is connected to a CRO. When a tuning fork is struck and then held next to the microphone, the following waveform is shown in the display of the CRO. The time-based setting of the CRO is 2 milliseconds per division. What is the best estimate of the frequency of the sound produced by the tuning fork? So what we can do is that we can see over here it's 2 plus 2, it's 4 milliseconds. The time period is 4 milliseconds. So from 4 milliseconds we can find the frequency. 1 over 4 milliseconds, 1 over 4 into 10 to the power negative 3 is 250 Hz. So C is the appropriate answer. Okay, so question number 24. Two electromagnetic waves have wavelengths of 5 into 10 to the power negative 7 meters and 5 into 10 to the power negative 2 meters. Which row identifies the region of the electromagnetic spectrum to which the waves belong? I have taken this from the Cambridge book. So you must recall this whole thing, this whole table. You must, the values must, that's a recall question basically. So B is the correct answer, 24B. Question number 25 says a transmitter of electromagnetic wave is placed 45 centimeter from a reflective surface. The emitted wave have a frequency of 1 gigahertz. A stationary wave is produced with a node at the transmitter and a node at the surface. So at the surface there is also a node, at the transmitter there is also a node. In between, how many nodes are there? how many antinodes are in the space between the transmitter and the surface. You have to find. So that's a repeated question. This question was repeated in summer 2013. Question number 13. So we just have to find first, we have to find the lambda. Applying V is equals to F lambda. Lambda equals V over F. V is the speed of light, 3 into 10 to the power 8, because it's electromagnetic wave. So divided by the frequency, which is 1 gigahertz, 1 into 10 to the power 9, gives 0.3 meters. So wavelength lambda is 0.3 meters. So the distance is 45 centimeters or 0.5 meters, 0.45 meters. So n into 0.3 divided by 2 equals 0.45, because the distance between node to node is how much? It's lambda by 2. So this equals 0.45. So n becomes 3. So there will be 3 nodes and 3 antinodes. So 3 is the appropriate answer. Question number 26 says, which statement about a light wave and a sound wave is correct? Both can travel through free space. No, sound cannot. Both have a frequency inversely proportional to their wavelength. Yes, that is correct. So P is the appropriate answer. C says both have intensity proportional to their amplitudes. The first thing is that for a light wave or a sound wave, the intensity is proportional to the amplitude squares. It's not proportional to their amplitudes only. So D says both have oscillations perpendicular to the direction of energy transfer. No, one is longitudinal and one is transverse. Question number 27 says, an outdoor concert have 2 large speakers beside the stage for broadcasting music. In order to test the speakers, they are made to emit sound of the same wavelength and same amplitude. The curved line in the diagram represents wavefronts. Where is the loudest sound heard? That's a straightforward question. You just have to realize that the maximum amplitudes are superposing here, so they both get added up at this D point. At C, B or A, you can see that they are not. So over here the amplitudes get added up, like A plus A becomes 2A, constructive interference. So maximum amplitudes, so it's D. So loudest sound is heard at D. Question number 28 says, an electromagnetic wave is incident normally on a diffraction grating. A second order maximum is produced at an angle of 30 degree to a normal to the grating. The grating has 5000 lines per centimeter. What is the wavelength? That's a straightforward question. Just convert this L 5000 by centimeter to D. How to do it? 10 raised to the power negative 2, convert the centimeter into meters. 10 raised to the power negative 2 divided by 5000. So it's 2 into 10 raised to the power negative 6, and substitute it into the formula. Lambda equals 2 into 10 raised to the power negative 6 into sine 30 divided by 2. 2 is because of the second order maximum, so lambda equals 5 into 10 raised to the power negative 7. Just apply the formula of lambda equals d sine theta divided by n. That's it. So question number 29 says, P is a point near to charge x as shown. When a negative charge, test charge, is placed at point P, it is found to experience a force of repulsion from x that is radially away from x. Which arrow correctly shows the direction of the electric field at point P due to the charge x? The first thing is that it's a negative charge and it is repelled. So what you can get is that if there is an electric field around it, the electric field moves from positive to negative, and if it's negatively charged, it is moving towards the positive electric field. So the electric field must be from right to left. So C is the appropriate answer. So that's it. Do not forget to like my video, share my video, subscribe my channel, and do press the bell button so that the next time I post a video you get the notification immediately. Thanks a lot.